This is third lecture on centroid. It deals with some special problems on areas. Let's take this problem, which has two rectangles, a triangle and semicircle. But the special thing about this is semicircle is on the diagonal, on the hypotenuse of the triangle, and therefore it does need some explanation. So what I'm going to do is I'm not going to spend too much time over two rectangles and triangle. I will get them on the screen, and if you followed the first lecture, then for area 1, area 2 and area 3, working of a, x and y will not pose you any problem. I will concentrate on explaining about area 4, that is the semicircle. In these like problems, your first step is to work out the radius of the semicircle. You have enough data in this figure. See, the diameter or 2r works out from the Pythagoras. See here, 50 square plus 40 square is equal to 2r whole square, and therefore r will come out to 32.02. Having worked out the radius, now we must work out the coordinates of the center of the semicircle. That is, center of this point which is shown as dark blue. Now, simply by observation on the figure, you can see that x coordinate of the centroid is 80, 40 plus 20 plus 20, and y coordinate is 45, 20 plus half of 50, that is 20 plus 25, that is 45. Having done these two basic steps, let's work out 4r by 3 pi, 4r by 3 pi, which for this radius will come out to 13.6. Now, the red cross is the location of the centroid of the semicircle whose x and y coordinate we need to work out. So we complete this triangle and we try to look at, or we try to find out what is this theta 1. For this, we realize that it is easy to work out theta, which is simply tan inverse of 50 by 40, that is 51.34. And then if you again look at the figure, you realize that theta 1 is actually 90 minus theta, which works out to 38.66. Now I think we are reasonably well equipped to go further. So let's put this working up here, and let's look at what is x1. Easy. It is that 4r by 3 pi or 13.6 cos theta 1. Number comes to 10.61. And similarly, let's work out what is y1. 13.6 sin theta 1, which comes out to 8.5. Now, these x1 and y1 numbers we need to add to the coordinate of the center of the semicircle. These coordinates we already worked out, 80 and 45. And therefore, finally, x coordinate of the centroid of the semicircle, the way it is put, is 80 plus x1, 90.61, and y is 53.5. And area of the semicircle, having worked out r, is easy, pi r square by 2. And therefore, we are in position to put elements of row 4, and then the usual sigma x, sigma ay, the ratios, and then the answer, x is equal to 65.81 and y is equal to 33.47. Look at the second problem. Special thing about this is there is a sector. That sector is lying at the bottom of the T. So what I will do, like before, is I'll quickly go over these rectangles and put the answers. You can easily look at them and verify them, and I will concentrate my explanation on the sector. Look at the sector. this area 3, the sector, let's divide it because we need half the angle. So we have drawn the dotted line, and half angle alpha is 15 degree because the total is 30 degree. Now 2r sin alpha by 3 alpha is the formula we use, number, and 2r sin alpha by 3 alpha is actually the distance from along the dotted line from the center of the sector, that defines the location of the center of the sector. We have drawn a red cross out there, and our task is to find x and y coordinates of the centroid of this sector. Now 2r sin alpha by 3 alpha is 65.94. This distance we have marked here, and we have completed this triangle. And now cos alpha, that is cos 15, can be written as x1 upon 65.94, which gives x1 as 63.69. But mind you, this is not the x coordinate. This x1 is the distance from right side. X coordinate of the center of the sector is to be measured from left side because y-axis is on left side, and therefore x coordinate is 100 minus x1, that is 36.31. Now the y coordinate. Similar steps. You get y as 17.07 with negative sign for obvious reasons, that it is below x-axis. And when these two are in place, we are in position to write third row, where under area we have written area of sector, which remember is r square alpha, where alpha is 15 degree. But mind you, don't do 15 into 100 because alpha is to be used in radians out here. So if you do that, you will get the area, and then sigma a, sigma x, sigma ay, the formula and the answers. X is equal to 43.62 and x coordinate is this, yc, that is y coordinate, is 3.62. Let's quickly look at one more problem. Look at this. When you see a problem bit complicated like this, you have to spend few seconds over it and realize or work out or mentally sort of decide as to which standard figures make it. See here, now it's clear. Two triangles, a reverse sector, from which if you take out semicircle, you get the required figure. We go row by row. First, a triangle, not very difficult, not very difficult. So, area. You can a little bit thinking and you'll get this, no big deal. Area 2, similar triangle, same area, same y's. X are different but not very difficult to understand. So I'll skip this and concentrate on this sector, which you see is a reverse sector. And little bit of trigonometry tells me that if this r is 100, this is 60 degree, this is 60 degree, therefore full angle of the sector is 240 degree and half angle of the sector, which we need for this 2r sin alpha 3 alpha, is 120 degree. If I plug in r and alpha, I'll get 27.58. It means the centroid, which is located at 27.58 above this 50 line, and therefore y coordinate is 27.58 plus 50, that is 77.58, and you see the way it is located, x coordinate is 100, and like before, the area of sector is r square alpha. You work it out and you will get a, and then you do sigma x, sigma ay. Oh well, no. See, one area missed out. Well, this usually happens. Just as happened to me. So one more area remaining. Let's not hurry it. We have that semicircle which is to be taken out. So easy. 4r by 3 pi is the location of the centroid, which comes to 31.85 above 50 lines. So y coordinate is 50 plus 31.85. That is 81.85. X coordinate is 100, and area pi r square by 2 will come to 8831.25. Negative sign don't forget, because area is to be removed. And now I again patiently say, yes, God, for all the areas, now I do sigma A, sigma X, sigma AY. Here I use formula, and here I get my result. X is 100, Y is 59.2. You could have got X is 100 by observation. But it's better to work out, get X as 100, and then be happy that, oh, it is as expected, because of the symmetry of the problem. But I strongly advise, don't use symmetry directly in examination, because under the tension you may miss out something. So best thing to work out like this and put it across. Answers are X is 100 and Y is 59.2. Thank you. Here's Alani.